So hello everyone. So in the previous sessions we have covered our Python basics. So from this lecture onwards, what we'll do is we'll learn about functions. Functions. Okay, let's first see what these functions are and why is there a programming need of functions. As I said, whatever concepts we have studied so far, you studied about data types, you studied about operations on these data types, and then basically what you saw is you saw that we have data and we are going to manipulate that data. Okay, this is what you saw. And then data, as you know that there are different types of data, so that's why computer only understands binary. So for that thing we have to understand different types of data, so that's why data type came from. So I made a map in the previous lecture if you see that. So then to manipulate these we need operations. Okay, then there is another programming construct that if you now want to do something again and again, or if you if you want to have a branching, so that we call as control flow. So on this data and these with operations we also learned about control flow. So these 3-4 things were the major things that there are in programming. So now all the things that we're going to study, it's more or less for ease of programming and have a beautiful code and have a good style of the coding so that people can also see it. So now what are functions? So basically functions will be blocks of code. Okay, so functions will be blocks of code which can be executed multiple times in your program. So you'll have a block of code if you want to run it multiple times, if you want to execute it multiple times. So rather than writing it again and again, so what we do is we'll club that parts of the code together. Okay, so what functions are basically, so these will be some lines of code which I feel that it will be used again and again. So it can be used again, or maybe what you call it can be reused. So what we do is we'll club these things together and we'll name this some block. Okay, think it like this. If you need some items, so what you can do is you'll keep those items in a bag and then you'll carry that bag with you, and whenever you need that bag, so you can just open the bag and use it. So that's what these functions are. Basically you have some code that you will use again and again. Let's suppose you want to do something, you want to add numbers, so you can create a you know the logic for that, and there will be some statements. There will be some statements like this. Okay, so I have wrote here again, so because I know that this is not visible, this yellow color. So what I'm saying is that if you have some lines of code or some statements of code which you have to use again and again in the program, so what you do is you basically take these things together and club them together. Once you club, and then you give this a name. Okay, and then you call it once when you need it, you'll call this. So that's what function is. So functions are just the blocks of code that can be executed multiple times. So they're again the building blocks. Okay, they'll perform a specific task. And now what I said is function, basically it should be designed in such a way so that this is independent from the other code, more or less. So what I mean by independent is that, so these statements should perform something. It's not that you will just keep a thing and then it does not serve a bigger purpose. You can do that, but in functions what you should do is, if you have a thing that you feel is independent of other code and it might be used somewhere else, so it's better to make that a function. So what are the important things? Why do we use these functions? The first thing is code reusability. By code reusability I mean that in functions you can make your code such that you'll reuse it multiple times in the different parts of the program. Okay, and that's what it does. And then one more thing is code readability. Code. Now you won't see much of the things, much of the basic constructors coming. As I said, that basic things that we have done so far, that was the programming. But here now you will learn how to make better code. So as you will be working on bigger projects, so their code should be readable. There is that mantra which I am always telling you, that write once, read multiple times. So usually that's what we do. We'll write something once and it has to be read multiple times, because people will be working with you in collaboration for a bigger project. So your code should not be only read by the machine, it should be also human readable. Humans should be able to read it, so that if they want to add some functionalities or if there is a problem, it is easy to do that. The function helps in that. One thing is reusability and other thing is readability. And one more thing that I would say is abstraction. So what is abstraction? So if you are given an interface, let's suppose I usually give an example of car. So if you are driving a car, if you know there is a there is clutch, accelerator, and accelerator, gear, and brakes, and then you have a steering wheel. That's the interface for you. Okay, you don't know what's going underneath. So how is car running? How are these wheels moving? And then how I am going from one place to another place? You don't know the internal details. You just have an interface. You follow the rules. You just change the gear. You press accelerator, clutch, and gears in some order, and then you also have a steering wheel. If you do that, you don't care about what is going underneath or what is internally happening. That's what abstraction is. It doesn't matter if there is an engine or if there is some person. When you just turn the steering wheel right, if his air gets stretched right and he turns right, it doesn't matter to you. The thing that matters to you is what you have control over. That's what functions will give you. Functions will have some internal implementation sometimes. So what you will do is you will just know what is the function, what is the input that this function takes, and what is the output that it gives. Okay, that is what you will be concerned about. That's why it's called abstract. This also helps in abstraction. So you write a function, you are not worried about how it was internally implemented. It has to be taken care by the code writer. But if you are using somebody's function, inbuilt functions probably per se. So there you will see this element of abstraction is there. So one more thing is modularity, in which you will create your program in modules. Okay, everybody clear with what functions are? So functions are nothing but just bunch of statements which we name together. And why is there a need? Because we need these things. Code should be readable, code should be reusable, and there should be that level of abstraction also. Okay, so that is the whole things about what functions are. Now we'll see it in the code how to do it. Okay, now first we'll see again there are different types of functions also. So one are inbuilt functions and user defined functions. Probably you might not find these names somewhere, it's alright though. So types of functions. And why are these called even functions? Okay, we'll come to that also. So one is called as inbuilt functions or built-in functions. And then we have user defined functions. I hope that most of you have seen the lectures on functions when we were reading maths. So there what we said is function basically is like a machine. It is like a machine, it does something. And it takes some input and gives some output. That's the same exact concept that we'll be using here. So we'll give some input, then you have to process this input. This is like a machine. So here this thing is like a machine. It takes this input and processes it in some way and then gives us some output. Okay, that's what functions will be here. We'll give some input, then it will be processed, and then we'll get an output. Okay, that's what functions will do. And now inbuilt functions are the functions. So when you are coding in Python or maybe in any language, so there will be some functions given to you. Let's suppose print function in Python or printf function in C++. Okay, these functions will be part of the programming language that once it was developed, and these things were given, and you can just call these functions. We have been using functions a lot because we printed things on the screen, and that time we used print. Okay, when we basically took input, we used that function input. And we use a lot of functions. Okay, these are inbuilt functions. Then user-defined functions will be the functions. A user will basically it'll club some statements together, and then we'll name that function. Okay, I hope everything is clear so far. Any questions?
No, everything is clear so far.
Okay, let's go to the coding window and show you the syntax first. So how is this? Now we have to define, because we are more interested in a user defined function. So how should a user defined function? Okay, it's in every programming language that you can define a function of your own. So you can define a function in C, C++, Java, wherever you want. So I'll just show you the Pythonic way of doing it. So Python has a syntax. So what we'll do is, so usually this is how code is being written. We don't name the functions first. We usually test the code without even naming, then we'll club them together. Okay, let's go to that screen. I hope that screen is visible. So what we'll do, let's suppose we want to greet somebody. So I'll say print, and then I can say some hello. Let's suppose now I'll take name. See how I'm coding, because now I have not defined name. So what I'll do is I'll say name is equal to input, enter your name. Okay, so this is what I'll do. So let's suppose if I run this, so this has been stored in test.py. So what I'll do is I'll say Python. Let me again change the environment. There is test.py file, so we'll run that file. So Python test.py. So it's showing enter your name. I'll say Mahmood, let's suppose, and it's saying hello Mahmood. Now what I'm supposed to do is, as I said, that if we have some statements and we want to reuse this code, what we can do is we can club this whole thing together. So first we should see what syntax in Python. So in Python what we can do is we can name a function like this, define that's definition, and then we can say greet. Okay, and here we'll take name as an input, and then it can say print hello name. So let's disable this prettier. Disable the completions because it's auto completing the code. So here you can see that now I have defined a function. If you see the syntax of the function, so syntax is it is showing def over here. So if you see it's showing def, and this is the keyword that we'll be using. Then the function name, and then this is called as parameter. Okay, this is definition, function name, and parameter. So whole of this thing is called as function signature. So this is the signature of function. So then we'll take this as input, and then we are printing it. So then we have something called as function call. So we'll just call this function greet. Now I can't just greet Mahmood, so I can greet many people. Let's suppose I'll now greet Asif. Say Asif is not here, we'll greet Asif. And it should be a string. Let's call it like this. It's pretty hard to type with pen in one hand. So if I now type it, you can see hello Asif. Okay, this is how functions are defined. So you saw the syntax, you write definition, and then what you do is you write the function name, and then you write the parameters, and then you write the statements. Okay, let me write it so that it becomes clear. Okay, so here it is. So what we have is we have this def. This def is a keyword. Okay, which says definition. Okay, then we have function name, and then we have parameters. And then this colon, then we have this indentation, and then we write the statements. Okay. One important thing that I would like to add here is that usually what's the usual thing? How do we define functions in Python? So what is the way where we define functions? We don't define them in camel casing, so we write everything in small cases. Okay, everything should be small case. So whole of the function name is usually small case. This is usually a convention which people are using. So these are the conventions which people have been using. So when you will see a big code, let's suppose you want to contribute in open source, so there they respect these sort of conventions. So what are the conventions? The function name, this is in small case. So if you have, let's suppose, multiple words, and let's suppose I here wrote function name. So what I'll do is I'll write function, then underscore, then name. Okay, then I can write underscore 1. So this is usual convention. Okay, you will not write it like this, function name. This is not a convention in Python. So this is called as camel casing, if you know. Okay, usually people write this like this. Okay, then there is another convention. If some function is a utility function, so what you do is you'll put an underscore there. Okay, if it's a utility function. By utility, what I mean is that if it is a part of something and it's doing very small thing and you don't want to mess up the whole thing, so what you write is you write a function by using underscore. Then you can write, let's suppose, ABC. Again, the def will be similar and everything will be similar, but this is just the convention for the convention part. Okay, so this is our definition, this is our function name, and these are parameters, and this is the indentation, and these are the statements or the block of code. And here, this thing is called as function signature. Is everything clear so far? Any questions? So here again you have seen that now we have written our first function. So what we can do is we can do something else. As I showed you that we can write, let's say we can add these two numbers together. I can write define, I can write add, I can write a comma b. A comma b will be the parameters, and then I'll have to write the statement, basically the code that I want to get executed. So I'll write print a plus b. Okay, if this is called as function call, so I'll write this is called as function call. So now I can say add 2 comma 3. So if I just run this, you can see this showed me the 5. Okay, now one important thing that I wanted to tell you here, which is not even written in many books, or I have not seen much material on that, there is something called as application evaluation order. Okay, so I'll write that on the screen so that you see it. So there is something called as application evaluation order. Let me just turn the VS Code off so that it's visible. So what is this application evaluation order? So in programming, this order basically refers to a method or when you given arguments to a function. So because now you have these parameters. So you have a function, you have function name, and then you have these parameters a comma b. These are called as parameters. Okay, these two are parameters. because they take some values. Anything which takes a value, usually in computer science we call it a parameter, or maybe in physics also we call it a parameter which holds some value. Okay, and then once you give some values, you give this when you call this function, you wrote something like 2 comma 3. Okay, these are then called as arguments. Okay, so what I'm saying is that there is something called as application evaluation order. So in programming, usually when you give this these arguments to the function, okay, these parameters, when they take the value, so it is a specific order in which it's evaluated. Okay, so application evaluation order means the function arguments are evaluated before the function body is executed. So here this will be evaluated first, followed by this. Okay, so I'll write definition. So function arguments are evaluated first, followed by the function body. So what I mean by this is, let's suppose I have this function add, which I just wrote. I had that function add. Let me go to the VS Code back. So I have that function add. So this is my function add. So what I can do, if I write 2 plus 3 comma 3 over here, so what will happen is, first this thing will get evaluated. This 2 plus 3 will get evaluated first. So basically what will be given in as argument to this a is 5. Okay, so before function call, so what we are doing is we are evaluating arguments. Okay, so once we evaluate these arguments, then only we'll proceed to the function body. So now what is the answer that we expect? 2 plus 3, 5 will be given as an input, and then comma 3. So 5 plus 3 is 8. We expect 8 to be the answer. So if you see, this is the 8. So usually what do we do? So we'll first evaluate this 2 plus 3, and then followed by the function body, whatever the body has. Okay, what is this called? This is basically called as applicative evaluation order. So you must know these things, because once you code and then there are some problems. Some problems might occur because of this, and you won't be able to find these problems. And then you must know that there is an evaluation order. Okay. I hope this is clear, that once we give the arguments to a function, first it will go from left to right. So left to right is arguments are evaluated from left to right. First argument followed by second argument followed by third argument, and then outermost first. So if an argument is even a function call, so then outermost function is evaluated first. So this is called as application evaluation order. I hope this is clear. Any questions on this? I hope that everything is clear so far. So this applicative evaluative order. So now we'll see these, what the function arguments are. We'll have a detailed discussion on these function arguments. So let me just hide this VS Code for a second. Okay, now we'll see what these function parameters are in detail. Function parameters. Okay, spellings can be here and there, but anyway you will get the concept. So what function parameters, basically, as I said you that functions will take these values. Parameters is just a name used for them. Okay, whatever holds the value. So functions can accept these parameters, which are values passed to the function. Okay, so that they perform this, they perform these operations, or they perform these, do these statements with the data. Okay, and they'll be defined inside these parentheses which I have showed you. Okay, and there are different types of parameters. So one is called a default parameter. Default parameters. Then we have keyworded parameters, or keyword, we call them arguments after that, because we are now, once we give the value, we'll call them arguments. Okay, then we have keyworded arguments. Then we have something called as positional arguments. Then we have arbitrary arguments. They are also called as Verdaic arguments. Arbitrary arguments. Sorry for the terrible handwriting, because I am writing on the writing pad. Okay, so these are the types of these arguments. So these are also called as named arguments. Named args. Okay, so these are the types of arguments. So or function parameters. So now we'll have function parameters, and then we'll define them in a certain way, which will make them a different type. So first let's start with these default parameters, default arguments. So what are these default arguments? Okay, so when we write the code, so in these parameters you can give a default value. Okay, let me write a piece of code, so that you will see that what I mean by this. I just wanted to show you the example so that you directly see it. So this is VS Code. Let's save this and let's create a new file, code test1.py. Okay, so here what I can do is, so I wrote this definition, greet name, then what's the greeting that you want to greet, and then hello. Okay, so this over here, if you see it, so this over here, this is the default argument. I'm giving some default value. So if you don't give the value, so what I'm saying is, what to the programming language, I'm saying there is a default value that should be given. Okay, default arguments, they are the parameters in the function that have some default value. If value is not provided for these arguments during the function call, the default value will be used. Okay, in our case, so if you don't give any parameter, let's suppose I want to greet somebody, so I'll say greet, and then I'll write the name, let's suppose Fahad. Okay, now the second argument is there, because in function signature we have name as the parameter and then we have greeting. So if I give greeting as hi, okay, what will happen is that it will override it. It will override this hello. Okay, so if I now run this Python test1.py, so you can see that it says hi Fahad. So if I don't give this hi as an argument, so what will happen is this argument will be taken by default. That's why it's called default argument, and this is what makes it optional also. So yeah, now you can see hello Fahad. So this greeting over here, this has been given a default value. So again, to just reiterate, so what is the meaning of a default argument? So default arguments are the parameters in the function that have a default value. So if value is not provided for these arguments during the function call, the default value is used, as we showed it here. And once this default argument is given, it makes that argument optional. So you cannot even give it in the function call. But if you give it, then it will override the earlier value. So whatever the value we earlier had, so it will override that. So we showed you greet Fahad, and the example was greet. Then I wrote the name, let's suppose Fahad, and then I wrote the default value with hi. If I run this, you can see in the first case we got hello.fahad, this is the default value, and hi is the value that we gave, and it was it overrided the value, this hello overrided, the greeting was overrided. This is called as the default argument. Okay, now there is a little bit of caveat in this. Okay, let's suppose what I'll write is, I'll make a new file, because as I said that default arguments are overridden. Now let's suppose I'll create code test2.py. I create a new file. Suppose I create definition, I create add to list or some add in the list, something like this. So I create this as a function call. So what I'll do is, I'll get an element as an input, okay, element, and then I'll initialize a list. Let's call the LST, and I'll have this list as an empty list. Oh, sorry, something happened. Okay, so if you see this, I have created an empty list by default. So what I want to do is, if any element is given to me, so I'll append the elements. I'll say list dot append. So whatever element is given to me, ELE is given to me, I'll append that. And then what I'll do is I'll return the list. Return this LST. Okay, and again this has some default value. You can see that it is default. By the default value of this is, it's an empty list. It takes empty list. So when I call it, let's suppose I'll call it. So I'll call the function and then I'll print it. Print, say add list. Then I'll add one in the list. Now if I run it, let's see if I'm in the right directory. No, I'm not. Session 9, I suppose. This is test2.py. Yes. Let's now run this file. Okay, now you can see that list 1, this was initialized. Okay, but this is when I overrode the value, when I give this element, and here you gave 1 and you do not give any list. If I give list from my side, let's suppose I'll give list, let's suppose 4 5 6. Let's see how it works. So now you can see that 4 5 6 was the original list that I had, and 1 was the value that was appended to it. Okay, this one was appended to the list that I gave earlier. Okay, this is the default. If you don't give anything, so what will happen is it will give the empty value. Okay, now I want your answers. So here you saw that when we add this value, okay, so what we did is when we added this one, so we got a list in which we had this one. Is there a problem in syntax? Oh. Okay, this one was there. So what I am doing is if I call this value again, so what I said is earlier that the value will be overridden. So what is the expected output? So in the first call, 1 should be there, because now we are making again a call. Default value is list should be empty, and then we should get 2. So what should be the output? What do you say?
2.
Answers. So first it will be 1 and then followed by.
Followed by 2.
Everybody agrees on this? Who agrees on this? Just raise the hand. Okay, almost everyone agrees on this. So let's see. Let's see what will happen. Did you see it? It got 1 and it gave 1, 2. Second list was 1, 2. It did not override the previous value. You saw that? The answer is the first was 1 and then 1, 2. Now if I again call it. So if I now call it with 3. So now you can see that if I again call it, it will append the values to the earlier list. So what does it tell us? It tells us an important point. It's a surprise. Why is it a surprise? Because we thought it will be overwritten. So this shows that the output that we saw that it shows that default list is being retained, okay, across the function calls. So no matter how many function calls we made, we are assuming that basically when we'll call this, a new list should get created. Okay. So what is the reason for this? So what Python does is, so Python, the default list is evaluated only once, and it is evaluated during the function definition. It's not evaluated during the function call. Okay, when you have defined the function, that list gets created. Okay, and that list binds itself to the function. This is a very important concept. So the concept here is that because when you have these default arguments, let's suppose if it's a list, so what it does is when you define that function, it binds itself to that function. Okay, once you define it, it binds itself to that, and it is not basically destroyed. And after that, after you make the function call, the list is still there, and once you append that, you can see this behavior over here. Any questions? Yes, you have a question? That's a good question, so I'll just give you a rule. So the rule here, the question basically is that let's suppose if you have does it happen only with list or does it happen with any other data types also? So
Yes.
the rule of thumb basically is if the data type is immutable, it will override it. If it is mutable, it will not override it. As you know, the list is not mutable. List basically is mutable. Sorry, so list is mutable. That's why it's doing it. If it was immutable, like let's suppose a string or an integer, because they are these values basically are, you cannot change these values. If you change these, it will take the shape, it will override the values. But in the list, what you can do is you can mutate the list. So list these data types where they are mutable, you should take additional care, because there once that thing gets created, it is bound to that function. And if you as we saw here, if you append these things because it's a mutable, you can mutate. You can just append the things and it will keep on appending. The rule of thumb is that you have to see if the data type is mutable or immutable. So prove that thing, so let's go to VS Code back. So let's suppose if this was not a list, if this was some, let's suppose a number 10. Now we will just print it. Okay, print this ele comma list. We'll print both of these things. So add list. So one element is, and second is optional argument. So if I say 1, 2, and 3, and let's suppose I'll give it here 10, I'll give it here 20. Okay, this is 20. If I run this now, so you can see that the first thing I got is 1 comma 10, and then second thing here also I print these things. So I got 2 comma 20 because this 10 was overridden. Okay, and even I should not even return a thing. Let's suppose I should not return this. I'm returning none basically. So 1 comma 10, 2 comma 20, 3 comma 30, 3 comma 10. So this 10 is by default there. So if you just give it the value, because you know that this integer, you cannot mutate it, it will override it. And because this is not mutable data type. So if it is not mutable, it will override. If it is mutable, then it will add it. Let's suppose we have this list, and there you can mutate it, it just appends the value. I hope this is clear now. Is it clear?
Yes.
So here what I will show you is how to avoid this behavior. Now sometimes you don't want this behavior. Okay, for that it is better to define it as none. So if you want to avoid this behavior, so to avoid this behavior you can use a sentinel value like none. Okay, you should say none, and then I'll just write the same code. So I'll just comment this code out, this part. Maybe whole will comment it out. Now I'll say append to list. Okay, then I'll say element, and then list I haven't initialized it. What I've said, I had given a sentinel value none. Now here if you see, I have said if list is none, then create a list, because as you said, as you know that this gets evaluated in the body itself, and now it belongs to this function only. Okay, it will be evaluated during the function call, not function definition. Okay, these default parameters, what they are done, they are created during the definition of the function. Now it depends if it's overridden or not. So here on purpose, if we don't want such a behavior, okay, what we can do is we can give this default as none. So what we can say is if list is none, if no list is given, then create a list. Now this list that you can see on the screen, this is created in the function body. It belongs to this function call only. So when you call the function, it will be only created that time, and then we append it. Now let's suppose if we call the function, if we do the same things. So if we say print, and then I'll call the function and say append this 1, and we don't have a list. And similarly, we can say append this to append 2. Now I can say append 3 to some list which already has a list 1, 2, 4. Let's suppose 6, 3, 5, something like this. So we'll see the output of all these things. So now you can see 1 got printed, because now we can see that the list got created during the function call only. Okay, now how to prove that? Because once we call this again on 2, so what happened? This list was no more there, because this list once created in the body, it only belongs to that function call, only belongs to that object. So after this, if you see this list append, we gave a list 635, and I told it append this 3 again to the list. You can see 635, 3. Okay, this is how to handle these things. Okay, if you want a thing, that it should be destroyed after the function call. So now the point learned was that if you give the default arguments, so they are bound to the function definitions. Okay, and now it depends on the user if they want to override. If it is mutable, what will happen is it will be overridden. If it is mutable, it will not be overridden. If it is immutable, then it will be overridden. Immutable, we'll just keep on adding as in the list. Okay, or similarly, you can see that over here. Now, if you want to avoid this behavior, so what we can do is you can just say list is equal none. This again is a default argument. Okay, and basically you are giving a value there which is by default taken none. So now if you see this list of 1, by default none was taken. Now here how do we handle this is, now we create a list within the body of the function. So within the body, once we create that, now it belongs to that function call. Once we call that function, okay, and because there are different types of memories, and once you call a function, because that function call is given some memory, okay, and then it resides with only that function call. This list is only residing with that function call. So once we call once we call the same function on number 2, it basically created its own list. Okay, and that list again took none and 2. So again, once we made a call with the list, so this list only belonged to this function call. Okay, this is how to avoid this behavior. Is this clear? So now we had a detailed discussion on these default arguments. So now we'll have a discussion on the other types of arguments which we call as keyworded arguments. So I'll write it here. Keyworded arguments. So what are these keyword arguments? So they are also called as named arguments. So I'd also write it here. They are called as named arguments. So all this, why are we basically doing those things? Because at the end of these functions and these basic concepts, we are going to make a personal finance manager, and we'll use all of these concepts. And there you should know all these concepts, and we'll put everything together in that. And then you will make your own project also, in which probably we'll make in classroom app or something like. You will have an assignment separately which tests different details of the concepts. And but we don't need to be that detailed every day when you're coding. So once the assignment is done, then you will do a project on Python. So that's why we are covering all the nitty details. And after that, you will be able to put all these things together. So what is a keyword argument? So keyword arguments are passed to the function with the parameters, and the name is specified also. So there, when the parameter is given, its name is also specified. So it basically allows you to pass values of the parameters in order. So what I'm saying is, let's suppose you said some name, age, and gender. Let's suppose if these are 3 parameters that you want to see. So usually what you can do is, So if you want to do something like this, so you can you can say name. This might not be visible, so you can say something like this: name is equal to, let's suppose, Mahmood, and then you can say, let's suppose, age is equal to some 150 years, let's say, if he lives that much, and gender, I would like to call him male. Maybe he was laughing. And this is the function call how I'll make it. So this is name, and then the second argument I'll give it an age like this. So I'll say age is equal to, okay, and then for this male I'll again say gender is equal. So if you see over here, so with these arguments I also gave the parameter names. That's why they're called keyworded arguments. You have a keyword, and because this keeps track of the order. Okay, let me write the code and it'll be clear. I'll just insert a new page, show you the VS Code, and we'll create a new file. So new file is, save this file, let's call it code test3.py. Okay, so what I'm saying is, so I'll write this describe definition, describe person. So you can see that I'm also respecting the coding conventions that Python people use. I'm using everything is lowercase. When I have two separate two words, I'll use this underscore. So now I'll take three arguments. I'll take name, I'll take age, and I'll take gender. Okay, so in this what I want to do is, so I want to print the name, and then print the age and print the gender. So I'll say print. Now that you also know about f strings, we can use f strings in here. So I'll say name is name, then I'll say comma gender, or maybe age is, then I'll have a placeholder age, then I'll say comma gender is gender. Okay, now if you see this, if I just call this, I have to call them in order. So what I have to do, if I say like this, if I call this describe person, and then I'll call, let's suppose, Mahmood, and then I'll say age is 100, then I'll say gender is male. Okay, so now if you saw that there is an order which is there. So if I run this file, Python test.3. Okay, so you can see name Mahmood, age 100, gender male. Okay, now you have to respect that order in here. So order was because the first name appeared, then age appeared, then gender appeared. Now there is a natural question: what if we had more parameters? What if we had at least 10 parameters? Then it would be a problem. So problem would be, okay, we have to keep giving those in position. So it is better if we can somehow have a keyword. Okay, we can say, let's suppose I did this by mistake. I did this. I first said male and then I said age. Now if I did this in out of order, so what you can see, you say the name Mahmood, age M, okay, and gender is 100. So it is totally messing up the order. So in order to do that, we had to introduce those keywords. I am just giving you why has this been introduced. So okay, if you don't want to respect the order, but still you want the correct output, or you want have the correct execution, so what you can do is you can use keywords with them. You can say this is name is equal Mahmood, and then gender is equal male, and then age is equal to 100. Now you can see that I gave the names, even if it's out of order. If it's not in the order that is defined in the function signature, I gave this in out of the order. So, but still I hope that they should print the things that we expect. So you see the name is Mahmood, age is 100, and gender is male. So this thing is called as keyworded arguments. Okay, is everything clear?
Yes.
So with that also we covered positional arguments also. Positional arguments is that once you call without giving these names. So I just called Mahmood, and I called this like this Mahmood, and I called it age is 100. So let's erase this. I say age is 100, and then we have male over here, and if we run it, these are positional arguments also. So positional arguments means where you have to respect the position. Okay, so our positional arguments are passed to the function in order they are defined in the function signature. So how are they defined in the function signature? So they are defined like that. Okay, usually in Python 3.8 they gave a good feature. People didn't use it much, but there was a feature given like this. So if you have this name, age, gender, and then if you say comma backslash like this, usually we'll expect an error, but this is not an error. You can see that it will still run. and I'll show you why did they do it. Did you see name, Mahmood, age, 100, gender, and this did not have an effect? Okay, so what this was basically, this was if the signature of function was like this in Python. So it was a sign that these are positional arguments. You should respect the position. Okay, this was a sign. Probably you might not have seen such things being done, but if somebody is from Python 3.8 and they respect these conventions also, so it's a good sign that here you should give these order matter, and you should give only the positional arguments, and it won't take keyword argument. If I now said, let's suppose gender is equal to m, it should throw an error. Why am I showing should? Because sometimes I'm not sure how Python will behave, but it will throw an error. So here you can see that argument passed as keywords, keyword arguments. Now because we only need positional arguments. Okay, because we got some positional arguments as keyword arguments. That's what this slash is for. But if you can do it like this, okay, it should run. Name Mahmood, age 100, gender male. Okay, but if you just put this backslash over here, okay, so this is forcing the behavior that these are only positional arguments. You should not use keyword arguments. Is it clear?
Yes.
Okay. So now we saw we had default arguments if you want to give if you want to have some default, and then we saw a problem there. The problem there was that we if you give mutable things, then it will append to that, and there we learned a good concept that if you have these default argument, it is basically defined. It is bound to the function and on the function definition. Okay, and then we also saw how to bypass that if you want to avoid those surprises. And then we see keyword arguments. So keyword arguments are where if you have a list of arguments and you don't want to give them in the order, so it is better what you can do is you can just name it and put an equal to and give it as a keyword. Why is it called keyword argument or named argument? Because you give a name and then give the argument. And then we also saw positional arguments where position matters, and you have to give the arguments of the function in the order in which they were defined in the function signature. Okay. Then the second thing is arbitrary arguments, or which are called as variable length arguments or variadic arguments. Okay. Here Python basically gives us basically two arguments. One is called star, and they are defined by star. Okay. Let me write that also. So I'll write it here. So they are called as, oh, it's not writing. So in arbitrary arguments, what I said is that so they'll be followed by this star like this. So okay, they'll have a star like this. So anything which is followed by the star in these parameters, you should think them as arbitrary arguments. Okay. So there are now two types. The first you will see something like this with one star and with two stars. Okay. In one star usually they write it as args, and here they write it as QW args. Okay, we'll see both of these things. Okay, and now what we are discussing is arbitrary arguments. Okay, or they are also called as variable arguments. Okay, they are also known as variable length arguments. Variable length arguments. Let's take this args first. We'll see what it does. Okay, so sometimes you have a need. Okay, you have a need like this. You know that I'll give one argument. You know that I'll have to define a function which will at least take one argument, and after that it can take many more arguments. Okay, so how to define that? Okay, this is a real problem also. So let's suppose you know that in adding numbers I can add two numbers or multiple numbers. So you know that at least two numbers will be there, but there can be more numbers also. Okay, but you don't know how many numbers will be there. So it is better we should have some format, we should have some way of handling those multiple numbers. So if I am defining a function add because addition is a binary operator, so it requires two things to be there. So that I am sure about, a and b should be there. So also we can add other numbers also with this a and b. So but I don't know how many numbers will be there. Okay, I don't know, I have no idea about that. Okay, so now I want a way in which I can give a function these arbitrary number of arguments or variable length number of arguments. Okay, I should be able to give at least two or greater two or greater than two. So there is where this star args helps us. This star args helps us. Okay, let's go and see in the code how it helps. If you see the code, so we'll create a new file. Let's call this code test.test4.py. Okay, so now what I'm saying is I'll just create, let's suppose add function. If I want to add, or maybe multiply, def multiply. I know I at least what I can do is I can take two numbers. I can take a comma b, okay, because I want to multiply them. And after that, I don't know how many numbers will be there. So what I'll write is I'll write star args, star variable number of arguments. So after that, what I will do is I'll store this result in a number result. Let's initialize that to 1, okay, and then what I'll do is, or maybe I can take only one number. Okay, I'll just say a if I want to if I want a multiplied by 1, okay, and then I'll say if you have variable number of arguments except this a, you can also give them. So how to now handle that? I'll have to run a loop. So I'll say for numbers in this args, okay, for numbers in this args, what will happen is I want to multiply them with this result. First I want to also result multiplied by a, okay, that is stored over here, and after that the result should get multiplied by the other numbers also. So I'll say result multiplied equal to whatever is there in the nums, okay, and then I'll probably return this multiplication, or maybe print it, return the result. I return this result. Now if I call this one, if I call this multiply, let's call this with just one argument. Let's call that 2, because now you know that 2 comma 1, 2 multiplied by 1 is 2. So we expect the answer should be 2. Okay, so you can see it over here, but I want to print this. So what I can do is I'll write print. We'll handle this return statement. Here I'm assuming that you know return, but we'll handle it separately. So now if I run it, you can see that. Oh, why is it not printing? Was it stored? Can you see any problems? It's good that we have problems over here. Oh, it's running something else. Okay, I was not running the code. I was just opening it. Now you can see that this is 2. In the previous session, what I was doing, I was saying code test.py. I should have written Python. I was just seeing the previous command. So now you see that Python test4.py, it gives the results 2 when I just gave one argument. So here, if I now want to increase this, if I want to give 3, 4, 5 also, okay, I want to give more arguments. So what I said is, I said this a will basically take the first argument, okay, then this star args will take the 3, 4, 5, and this basically will create a tuple. I suppose this will create a tuple, and we can check that also. Let's first see. So you can see that it multiplied this 120, it multiplied 2 with 2, 3, 4 and 5. This is 120. That's 5 factorial basically. This is 120. So now if I want to see what this args is, so what I can do is I can just print type of args. So I suppose this is the tuple, type of args. Okay, so now if you see, this should be a tuple. So it's a class tuple. So this star args, what it is, howso and number of arguments you give after this a, it will pack them together in a tuple and pass it to this args. If we even want to print it, so what 2, 3, 4 will be printed. So let's save this. You can see that 3, 4, 5 was printed. Okay, this 3, 4, 5. 2 was 2 belonged to a, and this 3, 4, 5 it belongs to the star args, and star arg basically this is the tuple. Okay, and that's why, as you know, this tuple is an iterable. So that's why we can run a loop on this tuple. Is it clear? So this is the one way is that we wanted to give arguments, variable length arguments. We don't know how many arguments we wanted to give, but we wanted to give them. Is it clear?
Yes.
Okay. Now the second concept is that's of keyworded arguments. Okay, I'll just close this VS Code and go back to our notes window. So second thing is that's called as keyworded arguments. KW, you might have seen KW. Okay, so it's called as KW args, and here we write double star. Okay, why double star? Because here we'll give keyword also. We'll give keyword. As you know what keyword is the parameter name, and then we'll say equal to the, we have seen keyword arguments. So if you say name is equal to Mahmood, okay, so this sort of argument is called as keyworded argument. And now you just don't want to give the positional arguments. You don't want to give them 2, 3, 4. You also wanted to give name with it. Okay, if you want to give name with it also, so you will use this star QWARGS. You'll use this. Okay, this is called this. That's why KW is a keyworded ARGS is argument. You can use other names also, but this is the convention that people usually use. So in there, so what it basically does is, if you initialize a thing, so if you just give an argument to a function which contains this, it will create a dictionary. Okay, whatever you pass, like this name is equal Mahmood, age is equal 100, gender is equal male, it will create a dictionary. So this keyword arguments will be a dictionary, and we will basically have a hold of that dictionary. Okay, so we have seen star args. Okay, so it is some way a way of taking positional arguments. Okay, because here we can't give names to the things. The order in which you give, it is stored in that order in the tuple. Okay, if you give 10 comma 20 comma 30, this is the way they were stored in tuple. Okay, and if you have to go through it, and you have to go by element wise. But here now you have this keyword argument. So I said this keyword argument, it is stored as a dictionary. So this thing is stored as a dictionary. So when you will call this keyword argument, and you will have a function in which you have this keyword arguments, it will internally create a dictionary. There the complexity of searching for an element is order 1. So there you can directly go to that element by having, this is called as key, and this is called as value, and we have key value pairs. Okay, so this QW or keyword arguments, it stores those things with a dictionary, and if you want to find a thing, you just write that as a dictionary. Okay, let's go to the code and see it in action. Okay, so let's comment out this code and write the code for this keyword arguments. Let's say definition, I'll write keywords args, some function, I'll name it as it is, and then I'll say star double star kwargs. Okay, this is what I'm doing. So now you know that this is a dictionary. Okay, so now it has key and value pairs. Now I want to get the key and value. I'll print these values. Let's suppose I'll just print these values for, so I'll write the key and value for key comma value in this dictionary. So okay, how to get the items in the dictionary? So you should say in kwargs, then dot items. Okay, this is how you retrieve these items. So this item will return the key as well as values, and then you want to print them. So what you can do is you can just use an f string over here, print, and use an f string. Let's suppose key with the key, and comma args with the args, or with the value rather. I'll write value. Okay, but the assumption that here I have made is that keyword arguments is actually a dictionary. And let's also call this function with let's say name, age and gender. So I'll call it like this. Keyword arguments, name is Mahmood, so I'll say name is equal to Mahmood, then I'll say age is equal to 100, then I'll say gender is equal to male, let's suppose. So here now what you saw is that I also gave some arguments, but these arguments were taken by this star QW args, and it took them as a dictionary, and I can have the hold of them. Okay, so now if I want to print it, Python test.4, you can see that key is a key name, or rather than this key I can say name, and it's already, if I read the key, we should have changed the whole code like that then. Okay, so if you again run, you can see that name Mahmood, age 100, and gender. And if I just remove this key, and let's suppose I don't want this key to be there, I just want values, and instead of value I'll say key and value, just not like this, key and value. You can see that name is Mahmood, age is 100, and gender is male. Okay, now the thing is that this keyword arguments basically was a dictionary, and you can check the type also if you want to just confirm it. So print what is the type of kwargs. It should give you class dict. Here you can see this. Is it clear? Everybody with me, or are you sleeping? So what we have done so far is we have seen what functions are. Okay, what are the functions? What are built-in type functions, and why are they required? Even we answered the question why also. Okay, anytime you read something, the first thing is that you should answer the why part for yourself. Okay, why is it necessary? The answer to the why of the functions was that if you have a function and if you want to reuse that code, so this function is just a construct again. It's a construct. It is not giving you any programming sort of control over the things. But what it is doing is it is giving you a style of programming. If you have to reuse the code again and again, so rather than writing the code again, you should just write it once and read it and use it multiple times. And reusability. We also abstraction. It abstracts out of things. Okay. And we answered why is the function needed. And I pretty much hope that you were convinced and that there is a need of functions. Okay, you could name them other things, but they are pretty much like mathematical functions. You give them inputs and they'll give you some outputs. That's why they are called functions. And after that, you saw that there are built-in functions like print function is there. There is function of input, and there are other functions which are by default given by the Python. And then we saw we can have user-defined functions where user will define. And then we saw what is the signature of the function. This function takes these parameters, and now we're discussing about different types of these parameters or arguments, in which we saw 4 types of arguments at least. One is the default argument, and second thing that we saw is positional argument, and then we saw keyword arguments. Then we saw these variable length arguments, or which are called as variac arguments. And there we saw that we have 2 types of arguments. One type is that in which we have variable positional arguments. We write that with star args. So in that, when you give that argument, it will take it as a tuple. And then we have this double star keyword arguments. That is accept as a dictionary. That's the difference between. And now you can combine these things together with the normal arguments also. Okay, let's do that in example. Let's see that example also. We'll see that as an example. First, let's see what we have done so far. We have seen what functions are. Okay, and these are good things to make the map, because by the help of these maps, you'll remember most of the things. Then we saw the types of functions, and we saw the definition of functions, and then we saw parameters. Okay, in parameters we at least saw 4 parameters. I'm just writing in the overview. We saw default parameters, we saw positional arguments, and then we saw keyworded, and then we saw variable length. Okay, in which we have the star args and kw args. Now let's switch to the VS Code and we'll see how to combine all of these things together. Usually you will see a combination of these things being used. You won't see them just as they are. You will see combination of this being used. So let's see that. Okay, let's create a new file, code test5.py. Okay, and there's a new file, and we'll use a combination of these things. Okay, and with the doc string also. So here if you see, I pasted a line of example function. So I have given argument 1, and then I have also given star args, and I have also given star keyword arguments. So here I have also given a doc string. This is usually how code is written. If you see a big project, that's how code is written. So what I'm saying is, this is an example function. They takes a mandatory argument. This is my mandatory argument, and then it takes variable positional argument and variable keyword argument. So this is called as variable positional argument. This star args, and this is called as variable keyword argument. So these are the parameters. Okay, this is doc string which I am writing. Parameters arg1, it should be an integer or a string. And then argument, this can be any variable number of positional arguments, and qw args, this is a variable number of keywords, and it returns nothing. And this is what I am writing in the doc string. Okay, a simple explanation of the function that it is doing. Okay, I am also here printing this print argf, and then I want to print this args and this qw args also. So because this is just one argument, I am just writing one print statement. If you see it over here, okay, and then for this args, this is actually a tuple. So what I can do there is, this is an iterable, so I can just iterate over it. Print additional arguments, args in args, and I'll print this arg. Okay, this is for the printing of this star args. And then I have this is a dictionary, so I'll have to handle it like a dictionary. So this is what I have done. Okay, now if you see example function, I am giving 42. This is the mandatory argument, and then I have seen hello 3.14. These two are my positional arguments. And what then I have done after that, I have given name, age, city, and these are my keyword arguments, and I am using them in the combination. And now I want to run this. Hopefully there is no error. So Python test4.py. You can see that this belongs to class dict. We have printed it somewhere. No, this is test5. Sorry, test5. And now you can see arg1 is 42. Additional arguments given were hello and 3.14. There's additional positional arguments. Then additional keyword arguments were given name Alice, age 30, and city Wonderland. Was the concept of these arguments, variable arguments, clear?
Yes, they were very clear.
Now the question that you people asked is that can we rewrite this args anywhere? So let's do that and see what's the behavior of the function. Let's suppose define, we'll call a function, and then we'll write let's suppose star args first, followed by the mandatory, followed by these arguments which are mandatory. Okay, let's write that ar. Okay, and let's suppose we want to add these things together for. Okay, we want to print them for a in args. Okay, print a, and then I also want to print ar. So here if I call a function, I'll call this func. So I'll call 1, 2, 3, 4. So what I'm supposing is that this 1, 2, 3 will be given to this args, and then this ar will get this 4.
Yes, that
Okay.
is what I'm expecting as well.
Okay, so if I run this, so this is Python test.6. Have we made some mistake? Now it says that you have to add it after this. So we made a point that this has to be added after this. Let's now add it after this. We'll see what will happen. Yes. So now you saw one more thing in the Python is that this has to be added after this. Our mandatory arguments should come first, followed by the arguments. Okay.
Yes.
Okay, so this is the point made. So these things are not to be memorized also. As you saw that, I also did not memorize it because you can check them on the fly. Okay, if you want to check these things, and you can just check them on the fly. And similar will happen with the keyword arguments. Okay, first we should have the mandatory arguments and then keyword arguments. And this is again a design choice. This is totally designed. I had nothing to do with programming. Okay, this is a design choice. Designer designed it this way. Why? Okay, if I have to answer the why part for you, maybe what they thought is, so here let's suppose 1, 2, 3, 4. They'll have to do one thing. They'll have to check. Okay, they gave 4 arguments. So here one argument is mandatory. Okay, let's map the last argument to that. It is an additional overhead if you see it from programming perspective. If I was building this language Python, so there what I have to make a design choice. Okay, should I make it like this or should I give the programmer more flexibility? So if I give more flexibility, I'll have to do more things. It will become inefficient. So why will become inefficient? Because I'll have to check. Okay, given the coder has given 4 arguments. Okay, I'll have to check the length of arguments first, and then I'll have to see one is mandatory argument, and then we have other 3 arguments are basically these variable arguments. So now last element should be given if the order was reversed as we did it. If the order was like this, if the order was reversed, now I have to check first length is 4. Okay, 4th element should be given to this, then first 3 should be given to this. Do you see the overhead? Compute the length at least. Compute the length of these, and also see okay how many mandatory arguments are there. If there are mandatory arguments 3, okay, last 3 should be given to this, and then the rest should be given to this. It's a lot of work to do for a programming language. So for the betterment, probably what the Python designers they said okay, let's do one thing. We'll keep the rule that mandatory arguments should come first. Okay, after that you'll have keyword arguments, and that's what usually people do. And I haven't seen that's why I even did not know it, because the code that I have seen is everywhere they write this star args followed by these mandatory arguments. Like we have mandatory arguments first followed by these keyword arguments. And if you want to basically make a claim and test these concepts for yourself, it again comes to design choice. It's better not to read documentation, rather test it yourself. Okay, and it will also bring that mentality of if you are building a language, you have to take decisions. You have to, because we have seen the previous lectures also. There were many decisions that a designer has to take. Okay, how should this be done? How should that be done? And there are different alternatives to do the things. Okay, but it depends on the designer how he wants to design it. Okay, again to reiterate you, I'm not teaching basically you how to program things. I'm basically teaching you art of programming. So I hope many of you will be compiler designers or they'll be inventors of some languages. So there you will see these design choices, you have to make it. And then you'll have a language philosophy with you. You'll say that, okay, I want my language to be less efficient. Then you will sort of have to take decisions which will make your language efficient. Or if you have some other philosophy, my philosophy of the language should be, it should be maybe easy to read also, it should be also a bit efficient, then you will make design choices accordingly. But these things have nothing to do with programming. These have something to do with the decision, or when a designer is designing a language, that time he has to decide these things. Am I clear with the answer?
Yes.
Okay, so with this we'll end today's lecture, and we'll continue having our discussion on Python, and probably we'll release the assignment tomorrow or maybe today, because at least you have an understanding of functions now. Now I am